Today we're starting chapter 10, which is the intro, or not an intro, but it's the stats chapter of this course. So section 10.1 is using normal distributions, and it says we're going to start off with, let's see here, what you're going to learn today. Calculate probabilities using normal distributions, and that normal is an important definition we'll get to. Use z-scores in the standard normal table to find probabilities, and recognize data sets that are normal. So what does this normal mean? The graph of a normal distribution is a bell-shaped curve called the normal curve that is symmetric, or the same on both sides, about the mean. So it's the same on both sides around the mean or the average. So if we look here, this is the bell-shaped curve. And a normal distribution with mean mu, the Greek letter mu, not mu, it doesn't kill you if you say it like that, because other people will understand you anyways. And standard deviation sigma has these properties. The total area under the related normal curve is 1. And the total area corresponds with a probability of 100%. So 1 is 100%. That's everything that could happen. Everything that could happen is under here. About 68% of the area lies within 1 standard deviation of the mean. So if we take a look at this, let's just kind of take apart this picture. We have sigma, the mean, sigma minus mu, which is, mu, which is the mean, my bad, minus sigma, which is the standard deviation, mu plus the standard deviation. So this is minus 1 standard deviation and plus 1 standard deviation. This is the first bullet point. About 68% of the area lies within 1 standard deviation of the mean. This is the mean. This is down 1, minus 1 standard deviation. This is up 1 standard deviation. Down 1, up 1. Minus 1 standard deviation, plus 1 standard deviation. 95% of the area lies within 2 standard deviations of the mean. So you have the mean minus 2 standard deviations and the mean plus 2 standard deviations. And then lastly, about 99.7% of the area lies within 3 standard deviations of the mean. Here they have it broken up for you in sections. So this whole 1 standard deviation is 68%. The whole 2 standard deviation area from the mean is 95%. So if you're looking at it broken up by chunks, well, the first standard deviation is 34 and 34. You add them together, you get 68. And if you add all four of these areas, when I say add chunks, I mean like this area plus this area is 68%. And then if the 4 middle areas add up to 95, but the first middle area is 68, then it's 95 minus 68, and then you split that in half, and that's the remainder. And then you do the same thing for here, and then here. Notice this 0.15 and 0.15. That's because 99.7 is not 100%, right? And the total area has to add up to 100 because that's everything that can happen. And so there's a very small number of people or pieces of data that are outside of the 3 standard deviations. And so they're just like far out, but they're very, they're not a big part of the population. Okay. Well, I guess we can go over this real quick. Normal distribution has mean, mu, and standard deviation, sigma. And x values are randomly selected from the distribution. So this is saying x is between the mean and the mean minus 2 standard deviations. So if you look at this picture, we see it's between the mean is the upper bound, and then the mean minus 2 standard deviations is the lower bound. And how much is in here? Well, this chunk is 34, and again, we get that literally just by referring to this picture. Or memorizing the 68, 95, 99, 7 rule and splitting it up yourself. But since you have this picture for reference, you should just use it. So you have 34, and we have a section that's 13.5%. So if you add them together, then the area is 0.475. You just turn this into decimal form to find the area. So if I ask you to find like, oh, the area between, um, mu plus 1 standard deviation and mu minus 3 standard deviations, then you would add this 34, 34, 13.5. How much is this? 2.35. And you would just add them all together. And then if it said something like, oh, what's the area that's like less than 3 standard deviations below the mean? Well, less than means you're going to the left, and then 3 standard deviations below the mean is the mean, 1, 2, 3 standard deviations below. Less than means to the left, so it's like, oh, it's 0.15%, or area of 0.15, either or, depending on how the question is framing it. If the question might be something like, oh, what's the probability? Oh, here, let's actually take the same thing and frame it another way. What is the probability that a data value, x, is above 3 standard deviations less than the mean? Well, 3 standard deviations less than the mean is the same spot, but above is everything to the right. So I could just take 100, subtract 0.15, and get 99.85% or 0.9985. If you didn't understand that, literally just rewind 30 seconds and listen to me explain it again, because I did show you how I like count, like above means to the right of, below means to the left of, and how to find the chunks or areas that it's asking you to find. Okay, interpreting normally distributed data. The scores for a state's peace officer standards and training tests are normally distributed with a mean of 55 and a standard deviation of 12. The test scores range from 0 to 100. So, whenever it gives you the mean, you just plop that right down in the middle. When it gives you the standard deviation, you just add and subtract from there. So 55 plus 12 is 67. 67 plus 12 is 79. 79 plus 12 is 91. And then you subtract going the other way. About what percent of the people taking the test have scores between 43 and 67? Well, that's 1 standard deviation below the mean and 1 standard deviation above the mean, which is 68%. Again, just referring to our table or this nice little graphic. Okay. The standard normal distribution is the normal distribution with mean 0 and standard deviation 1. The formula can be used to transform x values from a normal distribution with mean mu and standard deviation sigma into z values having a standard normal distribution. A z value, or let's see, there's a different right here. The z value for a particular x value is called z-score for the x value, and is the number of standard deviations the x value lies above or below the mean mu. So the z-score just indicates a number of standard deviations above or below the mean. If it's positive, if the z-score is positive, that means it's above the mean. If the z-score is negative, that means it's below the mean. So if we're like, oh, something has a z-score of 1, okay, well then it sits right here above all this and below all this. And the way you get that is, the way you calculate the z-score is you take x, whatever data point or data value they give you or that you're interested in, subtract mu, which is the mean, and divide by sigma, which is standard deviation. Hopefully they have an example that I can show you real quick. Not here. Okay, let me just make something up. Okay, so going back to that, let's use the test example. So mean of 55, standard deviation of 12. So mean of 55, well actually I shouldn't need that. Mean of 55, standard deviation of 12. Okay. So mean 55, SD is 12. I can't type mu and sigma on a keyboard. So let's say you wanted to know like, oh, how many, like, what if you score, oh, okay, here we go. So let's say someone got a score of, so we got 55, we got 67, we got 79, we got 91. But you're like, oh, well, what about like everything in between that, right? Like, because not everyone scores exactly on in one of those numbers. And we're like, okay, well, you want to know how you compare to everyone else with a score of like 70. So you're like, okay, like 70. That's above, 55 is the halfway mark. You know you're above more than half. This chunk right here is 34%. So you're already above 84%. But you're like, oh, well, how do I know specifically how much I am above? So we're going to take this x value that we have. And this is mega annoying, so I'm just going to type it out. Trash that. So let's see, 70 minus 55 divided by the standard deviation, which is 12. And let's do that. So 70 minus 55 is 15. 15 divided by 12 is 1 1/4. 15 divided by 12 is 1.25. So this is z-score of 1.25. If you wanted to round, which we have to because this is all that they're giving us to work with, like they're not going further. So 1.25, we would round to 1.3. So 1.3. That means if you had a score of 70, you scored above about 90% of people. You're in the 90th percentile. But again, we did calculate 1.25, which is a little bit below that, and we just rounded to 1.3 out of convenience. So really, the 1.3, if you scored if you scored and got a z-score of 1.3, you are in the 90th percentile. That means you scored above 90%. And where is that 90% coming from? Well, 1.3 is like one standard deviation and a third. So like around here, like you just slice the section into thirds and you take a third, the section to the left, and be like, okay, well, everything to the left amounts to about 90%. So you have 68 plus this chunk, plus this chunk, plus this chunk, plus this chunk, and that amounts to 90. That's what a z-score is telling you. You could definitely work. This formula works where you can work backwards if they give you a z-score and you know the out of these 4 bits of information, z-score, x, like just some data, piece of the data, x value, the mean, and the standard deviation, you only need 3 bits to find the 4th bit or piece of information. So you can, there might be a problem where they give you the z-score and you have to figure out the data value, or they give you the z-score and you have to figure out the standard deviation, or you have to figure out the mean, or something like that. And you could use this formula for all of that. Okay, recognizing normal distributions. So bell-shaped and symmetric. So not all distributions are normal. The first histogram has a normal distribution. This is normal. It has to be symmetric. It has to be symmetric about the mean. If a histogram is skewed, as in it does not look nice and balanced or even or symmetric, then it's not normal. So this is not normal. This is not normal. So then if it's not normal, then I can't say everything I've been talking about, like the z-scores or the normal distribution, the curve, or anything like that. Because look, like, how could I say, oh, if I go to the middle, half is to the left and half is to the right? Well, that doesn't make any sense. This area is it's like literally obviously much greater, right? So I can't do that. So yeah, I think that's it. Again, when you read this, just remember that mu stands for the mean and sigma stands for the standard deviation. And to refer back, like I would literally just be like, oh, which chunks sorry, not this one. Which chunks is it referring to? Not this one either. Sorry. And be like, oh, okay, well, from the mean, then these are the areas that I'm, trying to figure out.